Welcome back to Saravji's hut. Today we're going to be having some fun creating a Sudoku puzzle solver. Let's dive in. Today at Saravji's hut we're going to be having some fun and create a Sudoku puzzle solver. Let's get started. First, we need to talk briefly about what Sudoku is. All this information is courtesy of Sudoku.com. Sudoku is a puzzle board game, and the goal is to fill all fields on the board with numbers between 1 and 9, with the stipulation that each number only occurs once per row, per column, and per subsection of the board. Typically, depending on the grade of difficulty, the board comes pre-filled. This here is a very simple example from Sudoku.com that I will be using for illustration purposes. As a human, you solve Sudoku with logic. Using this subsection down here as an example, as a starting point, we are missing the digits 2, 3, and 5 to complete all 9 in here. Now remember, all the digits can only be unique in the subsection, in the row, and in the column. So in this case, because we have a 2 here, those two squares down here are not an option for the missing digit 2, which leaves only one possibility, and it goes in here. This is one way of approaching it with logic. Another way would be looking actually at the ones over here between those 3 columns. We know that we need to have a 1 in this column. We can't have it in this column or in this column because these 2 are already taken. For this square, we can't have a 1 in here, so it actually has to go in here. This is another logical way how to approach it, how to fill in a Sudoku puzzle. So how do we do it as a computer? As a computer, we are taking a different approach. Instead of trying to solve it with logic, we are simply solving it by trying. And what this means is we take the first square that is empty, so where there is nothing pre-filled or nothing filled in yet. In this square, we are going to be trying out each number from 1 to 9 and check if it is a valid number, again, within the row, within the column, and within the subsquare. 1 we can't use, 2 we can't use, 3 we can try out. So as a computer, we would be putting in 3 now here, and then we're moving to the next square. And we are simply trying out square by square, trying to fill out until we are getting to a point where we can't fill in a number because the configuration that we are having right now is not a possible solution for the board. Then we're actually going backtracking to the next one up, and we're backtracking until we actually get to a point. So let's say with the 3 here we can't solve the board, we can't have 4 in here, 5 would be the next one. So we start with 5 and we are filling again until we are hitting a roadblock or until we have filled in all squares. One such approach, how we can do this with the computer, is by using recursion and back-propagation. And this is what we're going to be implementing today, a simple recursion and back-propagation solution for solving this Sudoku. I'm using Spider as an IDE. Let's dive in. What I have already prepared is a CSV file. Let me zoom in a little bit. A CSV file where I have individual boards on here. I have formatted it in this way. So each 9 digits here are one row. We have 9 of these that are the rows one after the other. So one line is one board starting with only zeros, and these here are boards that are different degrees of difficulty that are pre-filled, that I simply copy down from Sudoku.com and put in here. Altogether I have got 6 boards, so we have 6 examples that we actually can look at how the algorithm is solving it. What I'm going to be doing is I'm going to be using a constant for my grid size and for my file name, and I'm copying in the code to actually save to file and load from file. This is not part of the puzzle that we are trying to solve, so I'm going to be taking a shortcut here and loading in my list of grids, so getting a complete list of all the grids. So it's a list of lists that I'm actually getting, in which I have all my grids in there, so I can select one or the other out of all the grids that I have to actually run the program on. Selecting one board out of all the boards that I have, and then the first part that I'm actually doing is I'm going to be creating a print board function that we will be using to print out nicely the board that we actually have right now. So let's create this print board function. There are always different ways how you can do it. This is the way how I like to do it. Building up a string, and then once everything is done for the string, actually printing it out. So what I'm doing here is I'm creating that subgrid of 3 by 3 squares. So altogether we have 9 digits in all directions, and we have subgrids with 3 by 3 in here. So for every row index, that modulo by 3 has a 0 return. So we are at every third line. We're going to be inserting a horizontal bar to create that separation. Then the new line character at the end, and I'm going with 13 because we have the 9 numbers, and then we have 4 additional characters for the outside frame and the 2 horizontal separators between column 3, 4 and 6 and 7. And I'm using the pipe symbol here for my horizontal separator. And converting my number that I now have in col to a string that I can simply add it to my result string. Now just add the right location, increasing my indices, then at the end of each line I need to add a pipe for the outside border and then a new line character. Increasing my row index and then closing out the output with the bottom border. So with that, we should have our string built up. So let's print it out and see what happens. We should be able to load our grid. We're selecting one, and we should be able to print out how the grid looks before we start filling it in. And this is how it looks. So we actually get our board in with the squares, with our lines and columns. The formatting looks exactly as intended, with a border all the way around and the separations for the sub-squares. Now, to solve checking for numbers being in our row, column, or our subsquare, there are different approaches how to do that. I'm going to be using an approach going down to actually checking in a list of 9 if the number is in there, and then answering back there. And there is a way of asking if the number is in there or if the number is not in there. So it depends which true value you actually are after. I'm going to be doing the negation right down at the bottom of the checking. So I'm going to be verifying that the number is not in a row, that it is a valid placement there. And I'm going to be creating a couple of functions now. I'm using one function to check if the number is in a list of 9 elements, if it is in there or not. And I'm going to be using this check for checking my row, for checking my column, and for checking my subsquare. So I'm going to be reformatting and data that I have in my grid in subfunctions that then are calling the check in the 9 function to actually verify it is in there. So what this function is checking, I'm checking if the number is already in this list of 9. If this is the case, then I am returning false. So because my number, and what I'm checking for is the number not in 9. So if it is in there, then I am returning false because the number is not in there. If I went through the complete list of 9 and I didn't get a true condition here that I had to return false, this means the number is not in 9, and that's why I'm going to be returning true. Now for number not in row, I actually need to find the row in the grid and then take this and check if this would be if the number is not in the row. Now, because my grid is a list of lists and my rows are my inner list construct, this is relatively simple to do. because my row simply is in the grid the list with the index row. So this is actually the easiest case to check for. For the column, it's getting a little bit more complex, but not much. We are building up our own list here, and then for we are simply going through all the rows in our grid, and we are taking the element at the column index, appending that to our list 9, and then we are again checking against these 9 if the number is in there or not. Now the most complicated one is the sub box, because we actually need to find the proper sub box and then take just parts out of multiple rows and columns to hand over to our number not in 9. Now how we actually can do that, we can use a little trick here, and we are simply subtracting from the row the remainder that stays from the modulo operation, and with that we are actually getting our top left corner row and column index of our 3x3 grid that we need to know to be able to go with the 3x3. And I can use the addition operator here, in this case for the list concatenation, because what I'm actually going to be pulling out is out of the row the 3 elements that are part of this 3x3 subsection of the main board. And with that, I'm doing this basically 3 times, adding a 3 element long list to my list 9. So I have again the 9 elements, and then I ask again if my number is not in the 9. So now what I have is I have a way to check if my number is in the row, if my number is in the column, or if my number is in the subsection of the grid, the 3x3 subsection. Now, the next thing what I need to know, and that I need to be able to answer, is if I want to check if a number can be placed into one index on my 9x9 board, I need to know if the number is a valid placement there. And we get our grid, we get the number that we want to check for, and we get its row and column index. So into which square in the grid do we actually want to try to place this? And this becomes then as simple as checking if number is not in row, and we need to give it the grid and the number and the row index, and we need to check that the number is not in column, and that is grid number that we want to check, and the column. And the last condition that this is a valid placement is that the number is not in the box. Grid number, row, and column. If all three are true, so the number is not in the row, the number is not in the column, the number is not in the box, we are returning true because it is a valid placement. Now what we need to do is cycle through the board and check for each spot if there is a valid placement. So what I'm creating here is I'm looking to solve for a valid number in one square of the complete grid. So I have a row index, I have a column index, and I'm simply cycling through all the numbers and check if there is a valid placement possible with that number in that location. And if this is the case, then I set into this grid, into this one square, I set the number to try. That is the one that I'm assigning there to. And with that, I have an updated grid. And I'm using this updated grid in a recursive approach. This function I still have to define. I'm getting to this in just a moment. And I'm going to be using this updated grid, or this updated version of the grid, to go for the next solution step. And in case I can't solve with this number in this location, I am returning this to 0, meaning I'm backtracking everything that I did to a point that I can get to the next number to try. And in case I can't solve for any number here, I'm returning false. So now I need the solve board function. And this is, I'm solving a complete board, so I'm starting with the complete grid. So what I'm doing in the solve board is I'm going element by element in my complete board, starting top left corner and checking if there is a 0 in there, which means there is no number assigned to this square. And if this is the case, I am solving for the spot, finding the number that is in there, and then I'm starting with the first number that is a valid placement in that spot and updating the board and restarting the whole process with this updated board, creating one iteration more here with the updated board and actually checking the rest of the board if I can solve it. And at the end, I'm getting back all the falses or trues that I'm getting, and then I know if I could solve the board or not. Now, the last thing that I need to do is actually kicking it off. So if I'm getting back a true, then it means that the board could be solved. And let's print out our board again, because now it's actually completely filled in. So we can fill in, or we can print out the filled board, the solution to it. And in case our solved board was not successful, then this means that we could not solve the board. Okay, so let's try it. So here you go. We are starting with 030450, and here is our solution. Let's double check. There is no double one in here. There is no double one in here. These are all the 9 digits. Let's check another one here. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. That is also fine. 9 is only once in there, and it's only once in there. So that works. Let's try it for another one. Let's try the first one with all zeros and see what actually happens there. So we start with all zeros, and interestingly enough, it is actually filling it with 1, 2, 3, 4, 5, 6, 7, 8, 9 in the top one, and then it's just filling in what is actually possible as a solution further down. And here you actually can see it's filling in 1, 2, 3, it's going over here, and it's filling in what is possible. And then for starting here, it's actually trying the first one that is possible, that is a valid placement. And in the row, we have only zeros, so all 9 are valid. In the column, it can't use 1, because 1 is already there, but because of the sub-square, we can't use 1, 2, 3, so the next one that is valid is the 4. So that is why it's filling in the 4, and then it's actually continuing on from there. Perhaps let's try another one. Let's get the index 5. And we actually have quite a number in here, so let's have a look. Yes, it all works, looks all good, so it appears to work. So with that, it's about 100 lines of code doing a nice solver, and this 100 lines includes the 2 functions to actually write to file and save to file, and read from file. I included the writing to file as well for reference. So here you go. With that, thanks for visiting me at my hut, following along, doing this Sudoku puzzle solver. If you liked it, give it a thumbs up, subscribe, leave a comment down below what other puzzles you would like to see solved. It is always fun doing these kind of puzzle games, cracking those, finding a nice solution there. It's always fun in between. So let's do this again. Stay safe. I appreciate you dropping by. Please subscribe. I'm done here. Fire to that.